Here is a mini lesson on section 5.1. So section 5.1 is an intro to linear equations or a review of linear equations, because we're going to use that later in the chapter for linear regression. So why is that important? Well, we often want to understand how two or more quantitative variables are related. So whenever we're doing regression analysis, we're always talking about quantitative variables. Regression analysis is just the method we use to examine the relationship between those two or more quantitative variables. Okay, that's all regression analysis is. We want to investigate the relationship. And in particular, we're looking at the relationship between an independent variable, all right, usually referred to as x, the explanatory variable, and what is the effect of that on the dependent variable or the response variable. That's y. So as we change x, what happens to y? Okay. And so in particular, there's all different kinds of relationships we can look at in statistics. We're in particular looking at linear relationships. So that means we're looking at linear regression, linear relationship. All right. And so when I graph or plot my data, I have two quantitative variables, x's and y's. We just want to find out, does it have a linear relationship? That's all we're doing. Well, how do we display the relationship between two quantitative variables, x and y? The most common way is a scatter plot. So we take our x's and y's. Here's this foot length example that is in Rossmann-Chance. Basically, this is just a set of ordered pairs. They took a sample of data and they wrote down foot length, and then they wrote down how tall was the person. All right, so they just took, I don't know how many people are here, 20 people, and they measured how long their foot was, and then they wrote down what their height was. And they want to see, is there a relationship between foot length, my explanatory variable, my x, and height, y. So we plot the data with a scatter plot. So each one of these data points here is plotted. So for instance, right here, 3573 is this dot here. It just means that to plot it, okay, we're always going to put the x-axis on the horizontal. That's my x, my independent variable, my explanatory variable. We know in this case, x represents the foot length. So this is x. All right, my y represents height here. All right, so this plot here is 3573, just means I come over to 35 foot length, and then I go up to 73 is my height. So each one of these coordinates or ordered pairs is a dot here. All right, so why is that important? Well, before we get to that, we need to have some definitions and language around how we describe scatter plots. So there's three important things about scatter plot. What is the form? What is the direction? And what is the strength of that direction? Form just says, what is the pattern that the points create? We're going to be looking at, is it linear? That's what we're interested in. Or it's nonlinear. We really don't want to deal with nonlinear data, but we need to know, what does it look like? The second thing is, what is the direction? This really refers to the slope. All right? So if the direction is increasing, meaning it's going up, meaning as x increases, if y increases, it means we have a positive slope. If x is increasing and y decreases, we have a negative slope. Okay? If it does neither, then we have really no pattern. And the last thing that's important about scatter plots is, how strong does it resemble the pattern? In our case, we want to know, how strong does it look like a linear pattern? So if I look at these three cases here, this looks kind of like, could be linear, right? And so we would say, oh, the form is linear, looks linear. What is the direction? Well, as x increases, y is decreasing. So the direction is decreasing. And when it's decreasing, it means that I have a negative slope. And the last thing is, how strong does it look like a line? We're going to use regression analysis in the applet later, but this looks pretty strong. I mean, the dots are pretty close. It just means how close are the dots around this line. I would say this it's strongly linear. If I take this other set of points here, yep, this looks linear. That's my form. Form looks linear. How about my direction? Well, as x increases, in this case, y is also increasing. So it's an increasing direction, meaning it has a positive slope. And then the strength, this is not quite as strong as the first one. I'd say it's like moderate strength. If we look at this here, this is definitely not linear. All right, this looks quadratic, so it's not linear. Okay, we have these other examples here. All right, this is linear here, and it is decreasing, meaning it has a negative slope. And I would say that it sort of has a weak linear pattern. This one here really has no pattern. It's not doing anything. As x increases, I don't know, sometimes y increases, sometimes it decreases. So we really have no pattern here. Okay. So now a quick review of linear equations. When you took algebra, the standard way to write a line was y equals mx plus b. M represented the slope, b represented the y-intercept. We still have all the same pieces, but in statistics, we write it in a different order. We write it as y equals a plus bx. The thing that I want you to remember is the slope is always stuck next to the x value. All right? It's the rate of which the line is increasing or decreasing. And the way that it does that is because every time x changes, you multiply it by b. Okay? So the important thing is the slope is always stuck with the x value. All right? Every time x increases by 1, we would add another unit of b to whatever the output is. A is the y-intercept, or also called the vertical intercept. When we had it in this form in algebra, b was our y-intercept. All you need to know is that when you have that constant alone, it's the y-intercept. It means where does it go through the y-axis. So here's an example. We have x, and then we have our linear form, y equals 1 plus 2x, right down here. This constant just represents my y-intercept. This coefficient of 2, which is glued next to the x, means it's the slope. All right, the y-intercept means that's where it goes through the y-axis right here. It goes through at y equals 1. X is always equal to 0. All right, because if it goes through the y-axis, x is always 0. Here's my y value is 1. The slope is positive. It's 2 over 1. It's positive 2. As x increases, y is also increasing. It's a positive slope. It's increasing. In fact, every time x increases by 1, y increases by 2. So x increases by 1, all right, y goes up 2. X increases by 1, y increases by 2. X increases by 1, y increases by 2. That's my slope. Here's all the different ways we can describe the x value, also called the independent variable, also called the input variable, x value. For the y value, we call it response variable, dependent variable, output variable. All right, let's look at some examples here. These are examples from the homework. Okay, so Dana invested some money in an account. The balance of that account is given by the equation right here. The balance B is equal to 8,050 plus 150 times T. T represents how many years since she invested it in the bank. B is the balance of the account. So if I write it down here, B equals 8,050 plus 150T. That is, I can equate it to the standard form. Y equals A plus BX. So if I break this down, this 8,050 is my vertical intercept. It's where it crosses the y-axis. Usually this is also the initial value. All right. This 150 is my slope. That's my B. Okay. Every year that goes by, my line is increasing by 150. And in this case, $150. So Dana tells us, the equation tells us that Dana started with how much money in the account. Well, when did she start the account? What would this T value be equal to? Well, it'd be equal to 0. When she first made the initial investment, the number of years it was in the account would be 0. So if I substitute 0 in this equation, I would just have B equals 8,050 plus 150 times 0. That tells me my initial account balance is $8,050. That's how much she first invested. Time was equal to 0 when I first invested. Okay? All right, so what's happening? This next one says, so we started out with 8,050 in the account, and that balance in the account is doing what? This is talking about what is the sign of the slope? Is it positive or negative? Well, the slope is positive. It's 150, so it's increasing. The slope is increasing. The account balance is increasing. At what rate? The rate is your B value or your slope. It's increasing at $150, and this wants the units per year. Per year, okay? T is the number of years. Every year that goes by, the account balance goes up by $150. I can write the slope like this, 150 over 1. If I translate this, every year, okay, this is change in Y over change in X. All right. Every year that goes by, X changes by 1 year, Y is changing by $150. That's my slope. All right, here's another example. We have this wireless charge service has this formula. C equals 29 plus 16N. N is the number of gigabits used. C is the monthly charge. All right, so how much I pay is equal to 29 plus $16 times every gigabit, N. All right, so I get charged $29 plus $16 times every gigabit, N. So the slope in this equation, well, can I write this? Or is this in the form Y equals A plus BX? Yeah, in this case, Y is represented by C, the cost I'm paying. A is 29, B is 16. The slope in this equation is 16. The slope always goes next to the variable, all right? Every time that variable changes, the y value is going to go up by that amount. The slope's units are, well, this is $16. I get charged $29 plus $16 for every gigabyte used, N. So this is $16 per gigabyte. Dollars per gigabyte. The slope is 16 over 1. Change in Y, change in X. For every dollar that goes up $16, the cost I get charged. Dollars per gigabyte. What is the vertical intercept? That's the same thing as saying the y-intercept. I'm just going to look here. My y-intercept is this term here, 29. What does that mean? It means when I use 0 gigabits, I still have to pay $29. All right, C equals 29 plus 16 times 0. When I use 0 gigabits, I still pay $29. That's what that also represents. All right, we have a student that's observing a reaction and then measuring how the temperature responds to that over time. She starts the reaction in the timer at the same time and records the temperature of the reaction every 30 seconds. So as time changes, what happens to the temperature? As X changes, how does Y respond? So it says, what is the explanatory variable? That's going to be my X value. That is going to be time. As time changes, what happens to the temperature? Okay. After the experiment, she graphs her data. What goes on the x-axis? Well, the x-axis is time. The y-axis is here, is temperature. Time, temperature. Okay, that's it.